Okay, it says 0 dropped frames so far. And I upped it to, so we're 1080p 30 instead of 720p 60. Okay. All right. Sound is weird. Let's try turning the sound up again. Because oh, now we're dropping frames. I moved my cursor and now, if we're going to drop frames just because I moved my cursor, that's pretty sad. All right, let's go to 96. All right. How are we doing? Let's try this. Make it 720p but with higher bitrate. I'm hoping that because it's text, the bitrate will fill in the text. I should go to 720. Now everybody's a backseat driver, man. The problem with going to 720p is I think the recording ends up in 720p. Is that right? Or is recording separate settings? Because I want to be able to record. Yeah, okay, let's try it. It seems like it's working. Okay. Welcome everybody. This is part 1 of us making a video codec. People have asked on Twitter, well, I expressed on Twitter the other day why I think it's a good idea to make a video codec, and so I will explain that to you now. So the context for all of this also is a speech that I gave in Russia last week called Preventing the Collapse of Civilization, in which I talked about how basically all software is way too complex for what it actually does, like an order of magnitude too complex at least, and that this is a real problem. And then instead of sitting around with our hands in our pockets, we should do something about it. So that's the background with which I was thinking about video stuff, right? So then I expressed why I didn't like the way video codecs are. I was giving these presentations and I can't play video in the slideshow program yet because it hasn't been implemented. And I thought, oh, what if I just try to implement this real fast before I go on stage tomorrow? And it's like, yeah, right. You have any idea how complicated it's going to be to just try to successfully use a video playback system, get one to compile and like link against it correctly? It's not easy. And that's part of the complexity that I'm talking about. So I expressed the problems that I have with all these systems, right? They're overcomplicated in many ways. So first of all, one of the reasons they all consist of like many libraries and they're hard to set up in your own new program is that they have this idea that there's like a container format for the video, that there's like a container and the content, and the container doesn't know what the content is and the content doesn't know what the container is. That's unnecessary. Nobody really wants that. Well, I won't say nobody, but almost nobody really wants that. It makes the implementation a lot more difficult. It makes it, more complex. It increases bugginess and all these things, right? Second, the idea, you can toggle around the audio format between many different ways of being stored and the video format between many different ways of being stored. And this increases the combinatorics of things and makes things confusing again, right? The idea that you should break I said audio playback code here, but I really mean audio and video playback code, that it should be 237 different libraries for some reason, right? I've never understood that. Even just playing back, audio, like if you want to play back Vorbis audio, you need libog, libvorbis, and libvorbis file probably, like for your minimal implementation, and it doesn't make any sense, right? There's no reason for that. And never mind that those like use zlib. Yeah. Anyway, those are the problems, or there's more problems. The idea that you should interface with OS installed codecs to play videos, right? That's just complexity and bugginess again. Like the idea that the way that you play video is first you install the codec on Windows, and then a video player looks up somehow who is registered to play what video type and then plays that back, and you get some mystery meat codec where the codec doesn't know what the player is and the player doesn't know what the codec is. That's wrong. You shouldn't do that, but that's how it works, apparently. And just E is this thing that happens with all kinds of software, but video especially. Like somebody works hard on solving a problem with software, and then they believe because they did that everyone who uses their software should work hard to use the software. And it's like, no, I want to just use the software, right? I want it to be very easy. I don't want to have to think at all to do something minimal with it. If I want to do something complicated or optimal with it, then sure, I should have to think harder. But I shouldn't have to think harder to compile it and get it into my program, right? Whereas with most of these systems, it's that way. And again, F, the idea that video shouldn't be simple to play, that I shouldn't just be able to load the file and say display frame 0 and not care about anything. Like most of these APIs aren't that way. The one that's the simplest is Bink, which is what we licensed for the witness. And the reason Bink is a successful commercial product, among other things, among the fact that it's very efficient at what it does, is that it's very easy to use. And it's not made by people who are overcomplicating all these things. So, what are my objectives? Like, why am I going off and making a video codec when I have all these other things to do? And the answer is the following. One, it's a really good test of the programming language because, you know, when you've got a codec, it's like, hey, I've got different pixel formats that I want to compress and decompress, and I've got, you know, maybe I've got several different settings for what my compression format is. Like maybe I've got a lossless and a lossy or something. And anytime you have options like that, it generates combinatorics in the code. Like you want to have a function with tight inner loops that do something. But then you've got to have like if statements in there and switching around things because you don't know what the input and output are, or perhaps you dispatch to like 27 different pasted version of the same functions with different things deleted from them in order to try to be fast. So part of our thesis is that with metaprogramming, we can make just one or a couple versions of that function. You don't have to rewrite them a million times or expand macros or do very ugly things, and they can cover all these kinds of cases optimally. We don't have code to test that yet. And so this is a very good way to test that kind of programming. Second is to provide a public good. Like we're going to give out the compiler. We're going to give out the libraries. And when we give out the libraries, well, this will be one of the libraries that we give out. So you'll have a video codec. You'll have full source code to it. It's probably not going to be the highest compression codec, at least in the beginning. We'll talk about that in a second. But it'll be there, and it'll be understandable and simple to read through. It'll be simple to use, and you'll be able to play with it, and you'll be able to make your own version if you want to. And it won't be like some kind of apocalyptic nightmare just to get it to compile. It'll be very easy, right? And then I can use it in the slideshow program in future presentations, and that'll be, I think, really fun. And I want to have fun. That's another objective that I have here. It's a fun thing to do in the middle of traveling and doing all these presentations. And I get to practice compression later. You know, I haven't done that much compression in a long time. We should all practice compression, as the Buddhists will tell you. But we can't do everything tonight, especially, or in these first few installments. So what are we going to do? We're going to, as quickly as possible, just go to some format where we can round trip and play back data without worrying about compression. Because compression is the hard part. Compression is where you need to have a big brain and work hard to make your file small. It's back. Okay, we had a short F. We'll take a pause here for a minute while the hotel Wi-Fi tries to come back. It looks to me like it's back. It looks to me like we're not dropping frames anymore. Okay. It's good now? Good now? Okay. So yeah, so compression is the actual hard part of all of this. Compression is the part where you need to be as smart as you can, and you need to work as hard as you can, and you're competing with people who have done a very good job, right? There are many codecs out there that compress videos pretty small. So we do that later. Initially, we'll do something dumb to compress, and in the very first version, we probably won't compress at all. We're just going to make a file format that has video and audio, and we'll be able to make videos, and we'll be able to play them back from within programs, and they'll just be big initially, right? But they'll be very easy to compile and use. And once we've got that established, then we'll go start thinking about compression, which again is going to be interesting because we want to avoid crazy patent land, which means we're going to have to compress in a way that's very different from how anybody else does. But that's things that we do later. So that's all that I wanted to say in that little preliminary presentation. Are there any questions? Because the next step is to just start writing code, I think. Any questions? Yeah, I'm sorry. We're doing this from hotel Wi-Fi, so I'm sorry if the quality is low, but we're going to put up a higher quality YouTube version later. Or I don't know. I mean, our alternative is just to do the programming later when we're on a better connection. We could do that too. If this is so bad that people are not getting, it doesn't have patent issues. Maybe, like people have said, MPEG-1 is now unencumbered, and we could do that. We could make an MPEG-1